stronger and the light cones get bent inward more. This makes it more difficult for light from the star to escape, and the light appears dimmer and redder to an observer at a distance. Eventually, when the star has shrunk to a certain critical radius, so it's become very compressed, in other words, very compact. Eventually, when the star has shrunk to a certain critical radius, the gravitational field at the surface becomes so strong that the light cones are bent inward so much that light can no longer escape. So this is showing that, where light can no longer escape. Okay, so this is the interior of the star. Light ray emitted at the time the event horizon forms is right there. So see how it gets, or this way is the distance from the center of the star, with 0 being right here, and this is time on the y-axis. Okay, so eventually when the star has shrunk to a certain critical radius, the gravitational field at the surface becomes so strong that the light cones are bent inward so much that the light can no longer escape. According to the theory of relativity, nothing can travel faster than light. Thus, if light cannot escape, neither can anything else. Everything is dragged back by the gravitational field. So one has a set of events, a region of space-time, from which it is not possible to escape to reach a distant observer. So you would not basically be able to get the information out from the black hole. This region is what we call the black hole. Its boundary is called the event horizon, and it coincides with the paths of light rays that just fail to escape from the black hole. So the paths where it just fails is the event horizon, okay? And after that, it's all black hole. See how it gets from lighter to more and more dark and black? That's because after the event horizon, nothing's coming out of there. It's all black hole, okay? No more information can be obtained or gotten out because even light can't escape. So there's nothing coming out again. And the surface, sort of just where light cannot escape anymore, that surface is called the event horizon. Light ray emitted at the time the event horizon forms. See? After that, it's done. Light ray emitted after event horizon forms. So everything, all the light kind of just stays in after that. And that's why right here we call that a singularity. It's a singularity because it's sort of this infinite density thing that's happening in space-time. Light cannot even escape that, and gravitation is very high right there, and it just goes from lighter to darker to darker to totally dark. That's what you see here, okay? Okay. I have to do a couple things here. I will stay online and see your comments and messages as I do this. Is black holes dark matter? So dark matter, the nature of dark matter is yet unknown and a topic of research. It is one of the biggest questions of the universe. The first one being what is dark energy, and the second one being what is dark matter. So whether dark matter is black holes or compact objects that could include black holes, that is a great thought. We talked about dark matter candidates, and indeed compact halo objects in our own galaxy were considered to be a candidate for dark matter, but we sort of disregarded them and did not think that they accounted for most of the dark matter, say, in our own galaxy. So at this time, we don't quite know what dark matter is. Black holes could have a role in dark matter. They could, or they could not. It's really not confirmed. We don't know yet. It's a topic of research. But it's a great question, so thank you.